Hello, so today we are doing this problem called binary subarray with sum. Um, it's a medium difficulty problem, and we get an array of 0 and 1s only, and we want to count how many non-empty subarrays that have the sum s. So for example, we have this array, and s is equal to 2. So the subarrays that we can construct are this that sum to 2 are this one, and this one, and this one, and this one. So that's four subarrays. So our goal basically is to count these with a value of s. And these are the constraint. We know that the values of a are either 0 and 1, and the sum is between 0 and the length of the array. So we don't need to handle a case where it's bigger. And yeah, that's about all that we are given. So this problem here is similar to a Leetcode problem called subarrays, the number of subarrays with some k, except here it's a lot of special where it's 0 and 1s only. But we can solve this problem in the same way, which is using just a hash map, using a map to count. So basically we'll use a map, and in it we'll put a sum as a key. So our key would be a sum, and the value would be how many number of occurrences of that sum. So basically what we will have is, let's just write the sum, and we'll have a count that counts how many subarrays we have. So this is our map. The sum's occurrence, and count is 0. And we'll go through the array. Let's call this A. And we will have an accumulative sum, so just a value that kind of for an array like 1, 0, 1, 0, 1, it would just keep track. So here, for example, it would be, so here it would be 1, and then if we advance 1 plus 0 is still 1, and then if we advance again, it would be 2. So it's just a cumulative sum. So that means let's initialize it here to s. And here we can just each time add the new value like we did here. And the point of this is basically if we have a sum, let's say a sum here at this value, let's call this value g. And then we have a sum somewhere else, let's say there are lots of values here. And we have this sum, this pointer here pointing at I. And the idea basically is that if the difference between sum j minus sum I is equal to k, what that means is that the values here, their sum is equal to k. So basically, let's call these values between, so that means that the sum between I and j, I plus 1 and j, is equal to k. So basically that means that we found a sum that satisfies the condition. Let's call this k here to avoid confusion. So that means that we found an interval of value that sums to k. So whenever we find something that gives us this, that means we found an interval. That means we can increase our count by 1. And so how can we find this? So the way we can find this is, since we have a map of sum and their value of occurrence, every time we encounter with this accumulative value a new sum, we can just check if already in the map there is a value that is a sum minus k. If that value exists, that means that, since this basically means that sum of I is equal to k, sum of j minus k. So if you found this sum, that means we found this one. That means we found the interval, and we can count. So basically that means when we increase the sum by the new value, the cumulative sum, we can just check if this sum minus k, so essentially this condition, is already in the map. Then we have this occurrence, and we have this interval that sums to k, and as a result of that, we can increase count. And so if this is the case, we can increase count by how much? So we can say 1, but that's not actually the case, because maybe the number of occurrences is 2. So there are 2 such sums. In that case, we can associate this interval with the j of one of the sum, and we can associate it with the j of the other sum. So it's actually the number of occurrences of this sum here, s minus k. And then after doing this, we can just populate sums map with the new sum. So that would be for the values that will arrive after this a, basically. And so this would be, since this counts the number of occurrence, we need to say sums of map s plus 1. But since this maybe it's not in the map yet, so we need to just do get s, and the default value is 0. And with this, we can return count. We are expecting 4, but we get 2. Yep, so there is one case that I didn't handle, which is, say we have k is equal to 1, right? So we need to count this array. But since there is no sum before this one here, there is no sum before it, we will count it as 0. So in order to avoid that, we can just put in the map map 0 to 1, so that this case can be added to plus 1. And so the way we do that is we can just say sums of map of 0 is equal to 1. Or alternatively, we can just say initialize it like this at first. So let's see. Okay, now it passes. Let's see if this. Okay, so this passes. Now, this solution can work with any values, not necessarily 1 and 0s. So we didn't take advantage of that. So let's see how can we take advantage of this one. Just before actually explaining that, I can make this a little bit more efficient. So since this is just counting, I can use counter. So I can just use counter here, which is a Python tool library utility that can just count the number of occurrences. And the benefit of this one is that if a value is not in the counter yet, then it just returns 0. So with that, we can avoid the need to check here. So that means we can just do count. And if the value, we didn't put the value yet, then we will just get 0, and we will add nothing to our counter. So that works. So this is counter. And since by default is 0, we don't need to explicitly say that. So we just can do this. And this is the same as doing plus 1. And we need to just handle the case where 0 and 1. 0 is mapped to 1, so that we can do this. We need to import it. So from collections. And this passes. Now, let's get back to the solution that we were talking about that takes advantage of the fact that the array contains only 0s and 1s. So how can we do that? So so the way we can explain this is, say we have a set of values here. Let's say A, just to map a structure of a random array that we may have. And then we can have, let's say, B, 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 and then something like this. And then we maybe have other values. Let's say instead 0, 0. And some values like C. Let's say I have 0, 0. So when this happen here, and we traverse the array, what we can do is, so basically what we want is these values, let's say, are ones. So once you find, if k is equal to 4, for example, let's say if k is equal to 4, then we need to count this array, but also all the zeros before it can construct an array because they still sum to 4. So this one can get added, and then we can have this one, and then we can have this one. So for each zero, we can have one more array that sums to k, and the same thing to the right. So the way we can do this is we can have, so we just need to know where the first zero is, so that we can count all of this as occurrences of, as a number of subarrays we increase by 1. So we just need to find this place here. And in order to find this place, we can just keep track of the last one we encountered. So we can keep track of that using pref. And in order to know this sum here, we need to keep track of the start of it, the start of the first value that is not 0. So let's call that low. And we need to keep track of the value that gives us the sum equal to k. Let's call that high. So high can be first here, and then we can find that the value is 3. So we haven't reached k yet. So increase. So our sum is less than k. So we need to increase high to reach a value bigger. And then here we found that it's equal to 4, and we need to start counting this, 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 and this, right? And this is the main idea. So in this case here, if k is equal to 4, how can we count all of these? So all of this is basically just this plus this, right? The values here and the values here. So the values here are what? Are low minus pref minus 1, right? Minus 1, so that we can delete this one. So these values here are low minus pref minus 1. And these values here, they count for just one subarray, because if you take less than that, just these, that's less than k. So it counts only for one value, so it's plus 1. So this entire thing is low minus pref, right? And so this here, we handled the case where the sum is equal to k. Now, what if the sum is plus the value that we just encountered is less than k? And what if it's the other case is when it's bigger than k? Here we already handled the case where it's equal to k. That's the case that we handle over here, right? So if it's less than k, that means that the sum is less than k. That means that we need to move this pointer forward so that we can find, say when we are here, it's 3. We need to move forward so that we can reach a bigger value that may be equal to k. So this means that we need to move to reach a bigger sum. Now, if it's bigger than k, that means that we need to find a smaller value. And so we can move k to reach a smaller value, right? Sorry, we can move low to reach a smaller value. So we can move low to reach a smaller value. There is one thing we need to handle for this case. So if we move low, so let's say we moved, low was here and there was zeros. So we need to take care of keep moving low until we find value that is not 0, so that we can start counting. There is no need to count the 0 values. So here we need to do something where while the value at low is equal to 0, keep increasing low, right? Because otherwise, if it's 0, we haven't changed anything, so it won't help us much, right? So let's see how can we do this. And also the calculations that we did here rely on low being the first one value. So we need to make sure that that's always the case. Okay, so let's start doing this solution. So there is one case where if all the values are zeros, then we don't know where to put low and high. So our solution here won't work. So we need to handle that separately. So let's say if k is equal to 0, we need to handle that. So here we just are going to put to do handle this case. We can handle it later. Now let's initialize the values that we described. So low, we need high, and we need just this to have the length of the array. And let's initialize pref. So first our low would be here. So pref, we just can mark it with -1, anything before. So that would be -1 for pref. Low, let's start with 0, and high, let's start also with 0. And n is the length of the array. Let's also have something, a cumulative sum, that just calculates the sum so that we can know if it's less than k or not. And so that initializes to 0, and we need a count for how many subarrays we have, right? So that would be 0, 2. And now, so while low is not at the end of the array yet, and the value at low is equal to 0, we need to just keep advancing because our formula here needs a value that is not equal to 0. And so in that case, we can just keep increasing low and keep advancing high to go to the, so first they start out as 0, 0. If the value is, say, 0 here, we need to keep advancing until we find one that is not 0. And so we advance both. And then after that, so we need to make sure that we are still within the boundaries. And now we start doing these conditions. So we check if s plus the value at high is equal to k. So our I here is just this value high here. So if it's equal to this, and the other cases are if it's bigger than k, and else we choose when it's less than k. So this case here, we found a value, so we need to count this, basically. We need to add that to our count. So that we can just say low minus pref, as we calculated before. And we need to advance both high, so that we can check the next occurrence. Say we had another one here. Then in that case, we need to also count the occurrences of, so if we had another one, then we need to count also this occurrence, right? And so we are going to do high plus 1, and the sum increases by right? Now for this case, when it's bigger than k, we need to move LO so that we can get a smaller value, and we need to take care of this. And so moving LO is this. And since we moved LO, so now the sum has one less value. So the value at LO is no longer in the sum. And so you can think of this sum here as moving along with the values LO and high, lower and higher, basically. And we need to handle the case that we said here. So pref needs to be always the first value, the first occurrence of the previous ones, basically. Actually, the last index of the occurrence of the previous ones. So that means that we need to put pref to LO here. And we need to, if while LO is equal to 0, we need to handle this case. We need to keep increasing it, as we said here. And we need to also make sure that we didn't go beyond the length of the array. And now if it's less than k, we need to move higher to reach a bigger sum. So we need to do this. And we need to increase sum since it's now this. And that's basically it. And at the end, we need to return count. So we have, yeah, we need to handle this case if the sum is equal to 0. So let's just define a function, call it helper sum 0, and we can define this one. So for this one, we can just go through. So we have our count that we are looking for, and we have the sum, and we can just go through the array. And if a is equal to 0, then our count is plus 1, and the final result, let's call it, is going to increase by count. So why is it going to increase by count is because, say if we had 0, 0, we need to count 1, 2, and 2, and 3. And so first it was just 0, so this is just 1. If we add another 0, then the number of zeros is 0, 1 here, 2, and then 3. So it's the previous count plus the new count. So otherwise, we can just initialize the counter because we encountered a value that is not 0. So we can't construct any subarrays between that sum to 0 between these, basically. So whenever we reach a 1, we can just start recounting from 0. And then we can return the count here. And let's delete this so that I can have more space. 26 here. Why is it complaining here? Yeah, I need to do else if because this is shouldn't happen if this one is valid, right? So let's bend this. Okay, we have a wrong answer for this case here. So let's try and see why. We are expected to give 15 because the sum is 0. So that means that, so when the sum is 0, we call this helper sum, which means our solution here is totally wrong. Yeah, we shouldn't return count because this is reinitialized. The accumulative result is in result here. So we need to return that. And it still fails. Did it fail actually? Yep, it did fail. That's interesting. I'm not sure what is happening here. Let's see. So just to make sure that I didn't mess up any indentation. So we are passing A with the value zeros, and we go through them and we check if the value is 0, increase count, and we add count to result. And otherwise, we set count to 0 and we return 0, right? So this seems like reasonable. And if k is equal to 0, we just return that. That's interesting. Let's print, let's just print here to see if it doesn't. Oh, yeah, I see. So I just called this, but I didn't return it, which is really dumb. So it goes through here, and this doesn't handle that case. So it should be returned. Yeah. Okay, cool. Let's print this. And the solution passes. So yeah, so this basically, second solution here, uses 2 pointers and take advantage of the fact that we have just 0 and 1 in the array. Yeah, so basically the lesson from this one is using 2 pointers and basically listing all the use cases possible and handling each one separately. Yeah, that's it for now. See you next time. Bye.